So this first problem is basically just a glorified can you figure out inverses using a line, and it's starting out by doing all sorts of verbiage. If I charge $25 a day plus $2 a gallon for gasoline, then I would rent out for my cost would be, my charge would be basically that. Okay. If I want to, do I start with the total cost, or do I, when I'm calculating, start with the gallons? You start with the input. So if you're designing a function, you want to think about what numbers am I plugging in. That's the easiest thing to make the input variable. So, oops. How did that turn black? I don't want to know. Okay. A table of values. So, with 0 gallons, I'm going to charge, gallons. I'm going to charge $25. I think the easiest thing to do is, since the table has $5 increments, I'm going to say if I charge 5 gallons, 5 gallons at $2 per gallon is $10 extra. So, etc. So I start out with $25 at 0 gallons. Come on. And then $35 for 5 gallons. Label things. Okay. And then it's just linear. All right, next. Jasmine's renting a boat. She has a budget, and she wants to figure out an equation that tells her the number of gallons if she rents the boat. She has a cash budget. That's the input. So input, rental charge, output gallons. It's basically the inverse function. So I'm going to start Okay, so R minus 25. Notice R minus 25 is the amount of money she has for the gas. Then if she divides by 2, she can figure out the number of gallons. And note for this, on my table, R has to be at least 25, otherwise you're doing negative gas. Okay, and again, 5 gallons of gas is $10 extra. So if she has $35, she can take 10 halves, 5 gallons of gas, and so forth. You can certainly do it at $26. You just have to figure out it would be 0.5 gallons, and I don't want to plot that. So 25, 35. This is 25 rental fee input. Because based on how much money she has, she wants to know many gallons she can do. All right, and this is gallons. Okay, so what do I consider the input? Gas. And Jasmine considers the input to be R, the price. if you look on my particular thing, it says my domain. If you look on my picture, it's just going to be x greater than, g greater than or equal to 0. And then the price is going to be for the range. So domain range going to be at least $25. So that's a y-intercept in my curve. She has an x-intercept, so Jasmine has an x-intercept of $25 and a range that just goes up from 0 gallons. So notice if you have names for these variables, we don't switch the letters when we find the inverse. Okay. Yeah, I know most of you already know that, but you can always fast forward through that part of the explanation. All right, we got an equation. Let's see, we got 3 pieces. Linear to the left of 2, quadratic between 2 and 5, and then some sort of, what does 1 more than the input mean? Ha ha ha. Okay, so for x less than or equal to 2, we have negative 2 comma 4. Oh, look at that. It's linear, so we can find the slope. And the slope is, by George, 0. So this is a constant function. It's a horizontal line. Okay, so y equals 4 is for that part. Oh, but only when x is less than 2. Okay, so between 2 and 5, now, not equal signs, again, you just don't include it, but you don't say 3 because there are numbers between 2 and 3. So between 2 and 5, we have a quadratic. If they give you a vertex, they've made it a lot easier for you. And then you plug in the other point to find A. Okay, so let's see. Negative 4 is the y-coordinate. Okay, add 6. So it is 2. And so this is going to be 2x minus 3 squared minus 6 for that chunk. What about one more than the input? So I'm trying to leave a lot of space to write the actual function. This is just x plus 1. Okay, so f of x is going to be 3 pieces. First piece is 4 to the left of 2. Let's see. Then it's going to be 2x minus 3 squared minus 6. I'm going to cheat and move this over. You should line things up so that your bounds are more or less lined up with each other. Let's see, 2 to 5. And then x plus 1 for x greater than or equal to 5. All right. Using the graph to the right, let's see, we have 3 chunks of lines. Notice that you need to make sure you're obsessing about the x-coordinate. So 1 and 2. Okay, so the first function, so let me just do it this way. Leave this space and then say x less than 1, and then between 1 and 2, and then to the right of 2. I got 3 separate chunks. The third chunk is easy. It's just at a constant height of 3. The first piece has a slope of, let me make this purple, a slope of 2 and a y-intercept of 3. So this will be 2x plus 3. This one, the next piece, you have a couple of choices. The slope is definitely -1. We can use point slope form since we know a couple of points. We have, 2, 0. Or we can figure out if you back up to where the intercept would be if there was an intercept, we can see that that's 2. So -x plus 2 works. And I'm going to just write a little note. Okay, so you pick one of the 2 points. I said 2, 0. X is 2, y is 0. Fine. If you distribute that, you get -x plus 2 anyways. Okay, graph the piecewise function. What do we have? The first part is a parabola. Plot -5, 9 if that's in there. Trace at -2. If you graph on the calculator, you can make your life a lot easier. Trace at -2, you get -2, -9. And then trace at -3, you get -3, 1. -4, 7, -5, 9. If you plot points, just don't forget that you have to stop here. You can't go past this point. This one can go down, but you do have to have a stopping point at -2. Okay, 2x plus 1. Okay, plugging in -2, we have -2, -3. It's just off there. Plugging in 3, you get 6 plus 1 is 7. And then if I connect the dots, hopefully, oh yay, look at that, it works. Okay. Constant of 5 when x is greater than 4 and greater than. Okay. Fine. Absolute values have the same kind of vertex form as parabolas. So if I look at this, x plus 5 plus 3 in absolute value, the vertex is at -5, 3. And we're going to trace at -2, -3, up to -8, or, you know. Okay, so -5, 3. I traced already. You make sure that you stop at -8 and stop at -2. Open circle at -2. Okay. Square root of x plus 2 is half a sideways parabola. Okay, so we'll trace at -2, -1, 0, 1, 2. Okay, so if I trace at -2, I get 0. -1, 1. -2, 0. No, 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 no. 2 plus 2, let's see. 2 plus... when I get to the end here at 2, it's the square root of 4, which is 2. So this bends just like parabolas do. And closed in circles, and that's the only chunk of that. X squared to the right of 2. So... till you run out of space. Let's see. 2, 4, 3, 9. Okay, that's out. Notice that it looks like a line, but it's not really a line. And it's an open circle at 2. Anywhere you have a closed-in circle, look to see if you have another circle above it. You need to make sure one of them's open. Okay, domain. The domains, you can look at this and say, okay, what's happening? -2 gets filled in. And if you look at the previous graph, the previous page, you see that there's a hole at x equals -2, but it gets filled in by the line. So the domain goes all the way to 3 and has a hole between 3 and 4. If you look at the picture, you can find the range more easily. So notice that this just goes down forever from a height of 9. So, okay, what about this other one? Let's just look at this, get it on the same page. -8 to -2, and again, once again, the less than sign gets filled in. And then this gets filled in also. So it's just everything to the right of -8. And the range, let's see, how low does it go? Goes down to 0 and then gets up to 2. And then there's a little bit of a gap and starts up again at 3. The absolute value takes it for a while, but then the parabola takes it after that. So this one's going to be... okay. So notice that f of x is a rational function built out of two lines, and that's important. So we're going to find f inverse. Cross multiply. Both terms get multiplied by x. The easiest way to move the y's together is just to move the xy term over. Factor out y. Divide by 3 minus x. And we'll have, okay, so f of x, I'm going to write it down for neatness. Let's see, 5x over 3 minus x. All right, what's the domain? The domain on these rational functions, the domain is the easy part. It's what doesn't cause division by 0. So everything except -5. In this one, what would cause division by 0? 3. So the domain is everything except 3. And again, because this is a one-to-one function, the domain of the original is the range of the inverse and vice versa. Except you just have to label them with y's. Okay. Let's find g inverse for this function. Notice that since g is a square root, which means g inverse is going to be a quadratic, and that's not one-to-one. So let's find g inverse. Subtract the 5 off. Divide by -2. I don't have much room, so I'm just squishing it in a little bit. Okay, so g of x is going to be and g inverse. Let's see, we just need to square and then subtract 3. Sorry, -3. Okay, so what's the domain? Is going to be x greater than or equal to -3. Can't take the square root of a negative. Let me write that in blue. Okay. Okay, so this is a perfect square down 3, so this is going to be, the range is going to be y greater than or equal to -3. So notice that these work, but the range of this, well, there's 2 ways to do it. For easy way to do it is to just look at g. When, let me write this so you can tell it's an explanation. So this is going to be y less than or equal to 5. Sorry. Okay. All right, so interpretation. This is more practice with this. So it's f of t, so the t has to be the 3. So this is 3 weeks. Okay, for F inverse, you have to switch, so that's got to be the weeks. So 3 TMCs. Okay, next, f of 0, we go down from 0, so F inverse of 0 means find 0 as an answer for f. And go backwards. So that's -2. F inverse of 8. Okay, so if you're looking at F, you're looking for information starting at the top row. F of 6 is 7. F of -1 is 6. F inverse of -1 says look for -1. Oh, there's F of inverse of -1 is 8. All right, just a little bit more practice. Oh, gosh. How many times have we done this now? I'm tired of these. Okay. You could distribute the 1/3, but it's easier to just multiply by 3 first. It says use proper notation. Lovely. Ah, last page. Okay, is this function 1-to-1? Yes, it is. We have to use the proper notation, though. Spiffy. So, how do you get rid of exponents? The inverse. So, Alright. We know how to do these, so I'm just going to do them wicked fast. Start from the inside out. Okay, 2g of x. When you have an of x, you have to stuff the inside function into the template of the other. So f of thing is 2 thing plus 5. All right. And we're stuffing g in. And distributing to simplify. And there are no like terms, so then we're done with that. H, let's see, what's h? H is minus 2, and we're stuffing g in. G is thing squared plus thing, and we're stuffing h in. Okay, foiling out. Don't forget to multiply don't forget to multiply properly. Oops. Okay. And don't forget the other part after you've foiled. So combining like terms. Okay, f of h is, f of thing is 2 thing minus 5, and we're stuffing h in, and h was x minus 2. And we're done, finally.